Today we're going to talk about fossils. Everybody likes finding fossils out and about in the world, but how did those fossils come to be? How were they created? We're going to talk about that today and demonstrate how you can create your own fossils right here in your very own kitchen. First, we need to talk a little bit about fossilization. Fossilization actually isn't one thing. There are a number of ways to preserve animals, bones, things like that over the years. Actually, 5 main ways that you can fossilize something. The first way is permineralization. Permineralization is one of the most common ways that you fossilize bones. So when you see dinosaur bones and you get all excited, it's from permineralization. Permineralization is something that occurs when water flowing through holes in rock or bone deposits mineral inside those holes. And over many millions of years, the bone or the rock dissolves away, leaving just the mineral that the fluid left behind. That preserves the shape and the structure of the wood or the plant or the animal that was there in the beginning. None of the soft materials are saved, only the hard materials that carry the water. We're going to demonstrate that today. If I had a dinosaur bone, it might look something like this sponge. Bone is full of holes, believe it or not. The insides of a bone, the marrow, is full of holes. That's how blood moves through bone. Over time, as I bury this underground, the fluid will move through those holes and deposit minerals in the holes. And what I'm going to do today is take some water, and we're going to take some food coloring, just like you have at home, and you can do this yourself. And we are going to color our fluid red at first. And we're going to take this red fluid, and we are going to run it through our bone to see how the water carries mineral through the bone. So as I pour this into the top slowly, it will soak into the sponge and start to go down, gravity pulling it through the fluid, just the same way it would if I were, say, in a rock. Gravity pulls me down. And as you see over time, as more fluid moves through, more mineral gets deposited and more of the sponge turns red. Now that we've moved our water through the bone, the red mineral has been deposited. And as the rest of this yellow bone over time falls apart and the organic materials break down, then all that will be left is what's red, right? And so fossils such as fossilized wood or dinosaur bones or a lot of other things are mineralized in this way. Now, as we take those rocks and we bury them deep within the earth, the temperature of the water gets hotter and hotter, and different minerals react differently to different fluids. So in fact, some things that early on start to be deposited might actually start to dissolve again, and other minerals will flow in that are more stable at higher temperatures. This happens, and we call that replacement. And replacement occurs when other minerals come in later and actually replace the first minerals that form the rock. We're going to demonstrate this with a different color of mineral and a different fluid. And we're going to flow this through, and my red mineral will be turned into a blue mineral. And what will happen is the blue will actually come through and replace this mineral in this bone. Are we ready? Let's give it a go. So there you see, even though some of the areas the fluid didn't touch, and we still have our red mineral, but here in the middle where the fluid flowed through, we now have our blue mineral. So we get very complex cements and minerals that form through the fossilization process as fossils are buried and converted underground into rocks. And also it makes for a very complex and beautiful thing that we can one day dig out of the ground and hang on our mantle and admire.